Hello everybody, today we are going to talk about arrays. Let's write something like that, int a. Normally, when we define a single variable like that, our compiler allocates memory. In this situation it is 4 bytes, because we have integer variable here. And we can get value from the allocated memory by using identifier, and in our situation identifier is called a. And what if I wanted more than one variable, for example 10 of them? I could do something like that, for example. Int a, b, c, d, e, f, g, h, i, j, and I could just continue that, right? I could do something maybe easier, something like that. Int var1, var2, var3, var4, var5, and just continue that, right? But as you have probably noticed, it takes a lot of time, and all of the values have different identifiers. So I can't use them so easily because I have to memorize all of the names. And what would happen if I wanted not 10 variables, but 100 or even 1000 of variables? Well, it would take too much time to create something like that, and even if we did it, it would be a nightmare using something like that. And again, what will happen if I change amount of variables that I need? You probably can guess. It would be very time consuming. And that's why we have something what is called an array. This is how memory looks like for typical variables and arrays. Here we have the typical variables. As you can see, here we are defining int a and int b. And as you can see, there are many other things stored in memory between variable n and variable b. There might be, but it doesn't need to be like that. But there might be, so we don't know exactly where that variable a or variable b will be put in our memory. We don't know that. We just know that it will be 4 bytes, and it is called, it will be, we can access the variable by using the identifier a, right? Okay, but here we have an array. In order to create an array, we have to write after the identifier of our array, so in our situation this x, the square brackets, and in the square brackets inside we should put the size of our array. And it means right now that for here that we will create an array of 4 elements. As you can see here, an array is a series of elements. Series means that they are next to each other, right? They don't have other things stored in memory between them. They are next to each other and of the same type. It means that we can create arrays only of the same type. So we know that all of the guys here have what? 4 bytes, for example, because the type is integer here right now. So we know that if we jump 4 bytes further, we'll for sure meet an element from that array, right? Okay, now let's go back to our code and let's create an array. So let's create something like that, for example int array, and let's create an array that will be able to store 3 elements, right? So how to create an array? Type, next name, and in square we should say how many of them, how many of elements we will have. So size, number of elements, right? Something like that. And right now we know that we created 3 elements that are next to each other. They are the same type. Okay, and how to access, maybe how to get values from that elements, how to assign values to that guys. Well, we can use something like index. In order to do it, we should do something like that. For example, let's assign values there right now. I type array. Maybe let's change it to array, just a bit easier. Array, and in the square bracket, we are telling which element we want to take from here. We'll take element that index is 0. The element with index 0 is the first element. Okay, so I was saying here, for example, 10. Now let's do the same thing to other elements. For example, that way. Something like that. I was saying different values, and I just assigned to all possible elements something, 10, 50, and 256. Because we have 3 elements, right? The size of the array is 3. And as you have probably noticed, we have to count elements from 0, 0, 1, 2. There is no such thing like array 3 right now here. I can't do something like that. I can't assign things here. If I do it, of course, that thing will compile. But look, what is very wrong with that thing? Let's create that maybe let's make it 4 like here, so it will be easier for us to understand it. And now it's of course cool thing, but we can do something like that, for example. That's very wrong thing. Why? Because when we create something like that, we have something like that here, and as you can see, we don't have anything after that place, right? We don't know exactly what is after that place. There might be other things stored in memory after and before. So right now we are trying to assign a value to something what is here. We don't know what is it. We are trying to do it, so probably we've just destroyed something. We just assigned to something very important a value like that. So that's really bad thing. Okay, so we can't do something like that because we could destroy our program. We could assign to other programs something. So remember that we have to count from 0, 0, 1, 2, 3, 4. That thing, it doesn't exist. Well, we can't do it because it exists, memory exists there, but we can't, we shouldn't, we mustn't do something like that. Okay? Now let's see how to get the values from there. So for example, array, and let's do something like 0 equals, for example, that way, 0, 1, 2, and 3. 0, 1, 2, and 3. That are all 4 elements, right? That array, size of that array, so number of elements is 4. Let's build it, and as you can see, now we can see the values from that guys, because we use the index here. That thing is called index. Now let's try to maybe see what address have that elements. How to get address of element in the array. We are using also ampersand here, but let's do it that way. Address, and this time we are doing this that way. Array, and of course we have to add the index. So let's copy that 1, 2, 3, 1, 2, 3. And now we can see the address of all the guys here. That thing here is called hexadecimal. It means that we have 16 numbers in that notation. In our notation, we have 10 numbers. In notation, in binary notation that I talked about in the lesson about the bitwise operators, we have two numbers to use, right? 2 digits only. Here we have 16. Well, we can't have 16 numbers because we have only 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we only know that, guys, right? So if we want to have notation that have 16 numbers, we are using A, which is 10, right? B, which is 11, C, which is 12, D, which is 13, E, which is 14, and F, which is 15. And now we have totally 16 numbers here. I told you how to change notations from example, binary to the decimal notation. From the hexadecimal to the decimal notation, so to our notation, it looks the same. So for example, let's change 1 to A. And so I should just 1 multiplied by something plus 2 multiplied by something plus 3 plus A multiplied by something. And now we are in what notation? We are in 16 notation, in the hexadecimal notation, right? So we will do something like 16 raised to multiplied by 16 raised to A multiplied by 16 raised to, and now the position 0, 1, and 2. So 0, 1, and of course 2. And now what? We have 16 to raised to the power of 2, which is 256, plus 32 plus A multiplied by 1. A is 10, so plus 10, right? And we have what? 298. If you don't understand it, please go back to the bitwise operator lesson. And now, when I bid it, you'll notice what? That at the end, that things are moved 4 bytes. 0 at the end, now 4, now 8, so 8 minus 4 is 0, right? C, which is 12 minus 8 is 4. So we are moving 4 bytes by 4 bytes. And that's like I told you here. So they are next to each other. You might be like, hey, why I'm focusing on things like that they are next to each other? Really, believe me, it will be very, very useful thing. Because we'll talk about pointers soon, and you will be like, wow, okay. I'd like to also add that the address of first element in array, so that guy here, can be also achieved that way. So the name of array is address of that guy here. Let's check it out. Let's see if it's true. Maybe I'm lying. As you can see, the address is equal to the address, so everything is fine here. So if I do something like that, if address of array 0 equals, that's true. That thing should be, of course, executed. Let's check it out. As you can see, that's true. I am not lying. Okay, so that's all about the arrays. And now, as you can see, for example, I told you I want to have 500 of elements, integer x 500, and instantly I have 500 of elements, and they are next to each other, right? So that's really cool. And now I can change, for example, it to 300. I can change it to 1000. So cool. But please remember that this number here must be here before compilation. we can't have, for example, that way, C in A, and for example that. We can't get the size of array when after we run the program. It has to be here before running program. So it could be something like that, constant, which means that this variable will not change for sure. And yes, that way I can do it, but I can't take it from the user and say, hello, I want, for example, 500 elements. We can't do it. We have to use dynamic operations to do that. We'll talk about them later, but right now we can't do it because we have to know how many of that guys here, you see, we will have next to each other before compilation, so our compilator will be able to do something like that, because he won't be able to do something like that after running program if we don't use the special operators to do it. So with that guys here, if that construction, we can only say, hey, I want 100 elements, and that's okay. We can't change it after running that program. Okay, that's all in this lesson. Thank you very much. Hello everybody, today we are going to talk about multidimensional arrays. Let's start this topic from two-dimensional array, which are sometimes called bidimensional arrays. You can imagine two-dimensional array as the array of array. We talked in previous lesson about one-dimensional array, and now we know that the array like that is some kind of container, right, for variables of the same type. Let's look at this scheme, and I would like to remind, of course, that arrays in C++ are numbered from 0. And look, when we create typical one-dimensional array, for example int x, which size is 4, we are saying something like that. Let's create a container, right? So this thing, a container, one container, that will store what? 4 variables. One variable, second variable, third variable, fourth variable, right? So we have a container that can store 4 variables of the same type. They are next to each other. And each element in one-dimensional array, of course, is called variable. So we are creating a container that can store elements, and elements here are called variables. Okay, when we create a two-dimensional array, we are doing it that way. Int y, which is of course type integer name y, and after it we are saying that we want to create 3 containers, arrays, right? And each of that container will be able to store an array again of 4 elements, variables. So as you can see, that is the first container that got created, second container that got created, third container that got created, right? And inside that containers, we have an array. One array, second array, third array. And each of that array can store 1, 2, 3, 4 variables. 1, 2, 3, 4, 1, 2, 3, 4, right? So I draw here something like that, that arrow, and if you want to get to that value here, you have to write something like y11. When I write only y1 in brackets, it means that I want to choose the container number 2. So that guy here, right? y11 means that I want to get from container number 2, so I'm choosing the container number 2, an array, so I'm choosing the array, that 1, 2, 3, 4 variables, right? And I want to find second variable. I want to find value that is stored in a variable number 2, so that guy here. Okay, so in two-dimensional arrays, we store inside an array just another array. Okay? Okay, let's create two-dimensional array here. So, for example, let it be integer and let's call it by array. And let's make size of that the same as here, so 3 containers that can store arrays that we have size 4. Okay, and now let's check, for example, what is inside something like that. For example, here. Of course, there are random numbers because we are just allocating memory, right? The same as we are doing with the variables. So we have to assign a default values here. We can do it very fast that way. Now I've just assigned to all the variables right here 0. As you can see, now we know that everywhere there is 0. If you wanted to have different values in elements, we would have to use something what is called loops. We will learn them in next lesson. So right now we could only do it that way, and we could assign only things like that. But in next lesson we'll learn about loops and we'll be able to do it very, very fast, almost instantly, okay? And I'd like to also tell you now how are working addresses now. Let's check address of that guy here. Address of that guy here. One, 2, 3, and now 1, 0. Okay, and you just continue, right? Let's compile it. As you can see, address of by array of index 0 is the same as address of by array 0, 0. And next addresses are moved by 4, right? 0, 4, A, C, and again 0, and then it will be 4. As you can see, this is also a space in memory which is continuous. We can create multidimensional arrays, which means that we can create many dimensions. I could do something like by array of, for example, 2, 3, 2. That's okay. I can again do more dimensions. Most time you will use only one-dimensional arrays and two-dimensional arrays, rarely three-dimensional arrays, but it means the same thing. We have got right now 2 containers that will be able to store 3 containers, and that 3 containers will be able to store a container that will be able to have 2 values, right? So it's this array of array of array. Okay, that's all in this lesson. Thank you very much. Hello everybody, today we are going to talk about loops. Loop is something that will let us repeat a single instruction, block of instruction, as many times as we want to. Okay, let's start from creating a multi-line command, and let's see how does for loop work. For parentheses, and we can place a few things in that parentheses, like initialization, condition, increment decrement statement, and after it we can place the instruction to repeat. And of course we can place more than one instruction to repeat, but we have to use then the curly brackets, right? So we can group them. So it's the same like when we used the conditional statements, for example, if. Okay, let's go back to the easier version of that, and please remember about the semicolons here. Let's start from initialization. This place is this is a place where we can fast define a temporary variable and assign a value to it. So let's create a loop for, and let's define a variable called, for example, I, and let's assign a value to it, for example 0. And then of course I have to remember about the semicolon here. I can create here more than one variable, so I will use comma here, and for example g equals 5, but I don't need right now two variables, so let's just delete this. I'm just telling you about that so you will know that. Okay, so this is that initialization, and remember, this is the first thing that will be executed when our PC meets loop. Okay, so this is the first thing, and that thing won't be repeated again. So he will define, our PC will define that variable, and that's all. And after it, our PC will check condition, so that place here, right? And condition is working like in all other conditional statements, so condition is true when it is not equal to 0. Okay, so for example, I is lower than 5. If that condition here, let's add semicolon, if that condition here is not met, instruction to repeat, so that guy here, so for example that guy here, won't be executed at all. If condition is met, instruction to repeat, so that guy here, will be executed one time. Okay, so right now is 0 lower than 5, that's true, so that guy will be executed at least once. And after that, execution of that instruction here, or of course block of instruction, because we can use the block of instructions, the field increment, decrement will be executed. So this is the place where we can, for example, increment that guy here, or decrement, so do something like that. So we can lower it by 1 or increase by 1, okay? Right now we should increase that guy, so finally someday that condition will be met. So this field is the most time used to increase variables that are in initialization field, and variables from initialization field, so from here, are used the most time in condition field. So it means that expression from condition will finally change, okay? So right now that thing should be run 5 times. Let's add the end line here. 1, 2, 3, 4, 5. Right, let's check how does it work exactly. So I'm right now the PC. Wow, here is the loop. I have to define the integer, and so I have to allocate the memory for it and assign a value to that place, and that value must be 0. Okay, after it I'm checking if that condition is true. Is 0 lower than 3? Yes. Okay, so I will send this thing to the output. Well, let's change it to, for example, I right now. So I will send to the output 0. After it, I will increase that I. So right now I is 1. And then again I will check the condition. Is 1 lower than 3? Yes. So I will execute that thing here again, and I will send to the output 1. Okay, so again I will execute that guy here, and I is right now equal to 2. Is 2 lower than 3? Yes, so I will send to the output 2. Cool. So I will have 0, 1 and 2, and now again I will execute that guy here, increase it by 1, and I is right now equal to 3. Is 3 lower than 3? No, because 3 is not lower than 3, the condition is not met, and because of that, that instruction won't be executed at all. So if I were PC, I would just move to another instruction. So for example, to that guy here that is singing, right? And let's check it out. As you can see, we have 0, 1, 2 and Lala. So I wasn't lying to. And now you might be like, hey, where can I use it? It's a good idea to use something like that to assign values of arrays. So how to do that? Let's create, for example, an array that size is 4, and I want to assign values to that array, to all elements of the arrays, right? And how to do that? Let's create a loop, define integer number, and if I is lower than 4, then I plus plus. And now we can, for example, assign I here, or just 0, or maybe 5, or maybe 10, well, anything, right? Let's do something like that, for example. This thing means what? That if I were the PC, I would define that variable, and then I would check if 0 is lower than 4. Yes, so I would assign to array index 0, so to the first element 0, and I will increase, check, and then I will assign to the second element of array 1, and repeat until that guy here is true. So when the I is 4, that condition is not met, because 4 is not lower than 4. And right now we can also, for example, send this guy to the output values of that arrays. Let's check if it's working, right? That guy here will be commented. Let's see. And as you can see, we have 0, 1, 2 and 3, so everything is working fine. But look, we can do, for example, like that, so I can assign 100 values almost instantly. Look, wow, and this was really fast. Okay, we can of course also group that thing with the curly bracket. Let's do it that way right now. So I'm assigning value to the array, and after it I am sending to the output instantly. What would happen if I did something like that? As you can see, all the values in that arrays are random, right? We don't know exactly what is in memory, because we assigned after outputting, not before. Okay, so when I do something like that, everything works fine. Now I'd like to tell you about the infinite loop, which means that this loop will never end. I don't need to put anything in that fields here. Initialization, condition, increment, decrement station, I don't need to. When I don't do that, our loop will be infinite. So, for example, And let's see what's going on. Our program is going to execute forever. I will use now the Ctrl+C to stop it. Okay. And now, when it's good to use. It's good to use when we know something what is called break statements, but we'll talk about it later. I just wanted you to know that there is something like infinite loops, and there is a problem with them, because you can make sometimes by mistake infinite loop, and you can do that way. For example, integer I equals 5, and then if I is lower than 5, then I plus plus. But what if I did something like that? So I'm not giving that guy here, that field here. I'm not using it. Of course, this is infinite loop, because that statement here is always true again. Is 0 lower than 5? Yes, it will be lower than 5 always. So that's the same like I would do something like that. Right? And it's always true. So you must be careful to not to make something like that, like condition that is always true. Okay? So that's all in this lesson. Thank you very much.